possible scenarios and its interpretation when it comes to quadratic formula. So here too you have three scenarios. We will get three scenarios, right? Real and unequal roots, real and equal roots, and not real roots. So, but how does it look in a quadratic formula? So we are looking at comparing with ax square plus bx plus c being equal to 0. So on comparing, a is equal to 1, b equals to 4, and c is equal to minus 5. Okay, very important not to miss the signs. So now we directly have to use the formula, and that's it. Roots using quadratic formula. So we begin with finding d, which is b square minus 4 into a into c. So this is 16 4 square minus 4 into 1 into minus 5. So this we are looking at 16 plus 20, which is equal to 36. Now we have the formula x is equal to minus b plus or minus square root of t divided by 2 into a. So if you substitute things over here, it will be minus 4 plus or minus square root of 36 divided by 2 into 1. So we have minus 4 plus or minus 6 divided by 2, right? Square root of 36 is plus or minus 6. So we have alpha, which is equal to minus 4 plus 6 divided by, use brackets, divided by 2, which is equal to 2 divided by 2, which is equal to 1. While beta is equal to minus 4 minus 6 divided by 2. So this representation includes both the scenarios, and thus the answer will be split out at the last. So this will be minus 10 by 2 minus 5. So you can clearly see that roots are unequal but real. Both are real numbers, but they are unequal. So how is d? Is d value greater than 0, less than 0, or equal to 0? Clearly greater than 0. So when you have a value of d which is greater than 0, you always end up with real and unequal roots. Okay, so let's see the d value in the other two scenarios, and then we can come to conclusion. So next scenario is comparing with our standard form. So that is ax square plus bx plus c is equal to 0. Always put a 1, right? Never forget that. So a is equal to 1, b is equal to 6, while c is equal to 9. All are plus, we got plus. And now we have to find the roots with the help of quadratic formula, using quadratic formula. So we have d, which is equal to b square minus 4 into a into c. So b is 6 square minus 4 into 1 into 9. So this is 36 minus 36. So this is nothing but 0, right? So let's look at the roots themselves. So x is equal to minus b plus or minus square root of d, brackets open, brackets closed, entire thing divided by 2 into a. So we have x is equal to minus 6 plus or minus square root of d is 0 entire thing divided by 2 into 1 minus 6. Square root of 0 is 0, so minus 6 by 2, which is minus 3. So there's no scenario of plus or minus anything, So both alpha is minus 3 and beta is minus 3. Both alpha and beta are minus 3. So we are looking at a scenario wherein the roots are real and equal and d value is equal to 0. Right. So can you guess what will be the d value for the third scenario? So till now we looked at d is equal to 0, d is greater than 0. So what should be the third scenario? Make a guess before I complete the answer. So first thing is comparing with ax square plus bx plus c is equal to 0. A is equal to 1, b is equal to 4, and c is equal to 9. So we have finding roots using quadratic formula. So we are looking at d, which is equal to b square minus 4 into a into c. So 4 square minus 4 into 1 into 9. So this is nothing but 16 minus 36, which is a negative value. Now, how will the t look? I mean, x look? Well, we don't have the formula. X is equal to brackets open minus b plus or minus square root of d divided by 2 into a. Right? So, on substituting, we'll get minus 4 plus or minus square root of minus 20 divided by 2 into a. But we can't further reduce this to anything because we have a square root of negative number. So we know that when we get a square root of negative number, the roots are not real. They come under imaginary. They're not real numbers at least. They're not real numbers actually. So basically, if d value is lesser than 0, the roots are not real. If it's equal to 0, it's real and equal, greater than 0, real and unequal. And this is something that you guys have to remember. And it's logical also. It's not, it's very logical, right? So scenario 1, if you want to have a pause and look, please do so. Then we have the case 2, scenario 2, and we have the third scenario.